Hello, and good morning, or afternoon, or whatever time of day it is according to you. But what really dictates the time of day? Is it the position of the sun, or degree of angles made by shadows of objects? Well, yes, we could say that time is a way of measuring change in many different objects, but what if you were in the absence of all things, with no sun and no objects to cast shadows? Nothing changes here, so what is it that tells the time of day? Does time continue ticking, or does it cease to exist? It's a really interesting concept to think about, one that physicist Carlo Rovelli spent decades pondering. Rovelli argues that many of our concepts of time are false. For example, let's think about the meaning of now. What does now mean to you, and does it mean the same for everyone? You may think that now is in this very moment, witnessing things as they are. Modern physics points out that everything that you are looking at, feeling, or listening to is in the past. Your sense of now is not in the present, but in the past, because light takes time to reach your eyes, electrical signals take time to reach your nerves, and sound takes time to reach your ears. This amount of time is extremely small, on the nanoscale, which is something that humans can't really perceive. So we continue believing that now is now, even though it's only a few nanoseconds ago. But if what you were witnessing now was on a distant planet in a distant galaxy, you would be witnessing millions of years into the past. But even so, if you were to know how long it takes that light to travel from that distant galaxy to Earth, and you wait that long to find the moment that was now when you were looking, it wouldn't necessarily be the same now, because time is not only impacted by the distance that it must travel, but by relativistic effects, such as mass, gravity, and speed. So really, there is no true concept of now outside of our approximation we use to limit now to planet Earth. The second truth that humans live by is the fact that time is measured by clocks and is ticking the same for everyone. Even with our different time zones, the rate of change of time is the same for everyone on Earth. This truth is actually wrong. From Einstein's general relativity, mass and gravity slows down time, and with Earth being a massive object, time is slowed down in the space that's closest to Earth because it feels the strongest gravitational force. Your feet are actually younger than your head by an incredibly small amount. This difference is really so small that our perceptions don't notice it. So we carry on with our cultural perspective of time, but the difference might not always go unnoticed. If you could imagine humans orbiting around objects thousands of times more massive than the Earth, time is seriously impacted. Speed also has a lot to do with the passing of time. The faster rate you move in space, the slower rate of time you will perceive. So objects moving close to the speed of light will experience time much more slowly than slower moving objects. Because of relativistic effects, time is not the same for everyone. In fact, it is slightly different for every person on Earth because it depends on where they've been and how fast they've been moving in every single instance of their entire lives. Relativistic effects have been proven using atomic clocks that are based off of the decay of very stable atoms. In 2010, two ultra-precise synchronized atomic clocks were put next to each other. One of them was raised by just 33 centimeters. The clock that was higher ticked faster because it was farther from the Earth's gravitational field, feeling a weaker gravitational force. The faster rate of the higher clock tells us that the atom decayed faster here than on Earth. A lot of people are confused by this because they think that it's a mechanical issue with the clock, but it is in fact an observer's time that is changing. As was mentioned before, time is a way of counting the change of something. So in this case, it doesn't matter what the clock is. It could be the rate of a heartbeat that's changing, and this can denote faster effects of time. The idea of time being a way of counting the change of something was first introduced by Aristotle. This idea of time isn't the only one, however. Newton gave the idea that time is not just the changing of something, but it is uniformly flowing, regardless of whether something is changing or not. This concept should be really familiar to us, as it is how a lot of the world sees time today. But Rovelli argues that time is an illusion, that our naive perception of its flow doesn't correspond to physical reality. On top of our false concept of now, and our concept that time is the same for everyone, Rovelli explains that the distinction between the past and the future should be rethought. Of course we know the past is different from the future, but where does this distinction come from? The laws of mechanics, electromagnetism, the standard model of particle physics, general relativity, and other sciences don't have this distinction between past and future. There is only one science that sees the distinction between the past and the future, and that's thermodynamics. The law of entropy states that entropy always grows in the direction of the future, where entropy is the amount of disorder in a system. The universal entropy is always increasing, suggesting that the beginning of the universe was very ordered. Rovelli argues that this law exists because it is tied to approximations we make in describing systems and our perspective of looking at the systems. An example of this is to look at an ordered bucket of red and green balls, and then shake them up. You may look at the system and say that the entropy increased, but to a colorblind person, the entropy did not change. Entropy is a strange microscopic effect through our perspective that helps us define the direction of time, but this doesn't exist in other sciences or even microphysics. What Rovelli believes makes entropy lower in the past is not because the universe was more ordered. The universe was whatever the universe was. It is the fact that we interact with the universe such that under this perspective, the past was more ordered. So maybe time is just an illusion to us. Rovelli states that there is very little time in nature, and many of our mathematical models describing the natural world can be written in a time-independent manner. The time variable in many of our equations doesn't exist in a lot of our fundamental equations like Schrodinger's equation, the Wheeler-DeWitt equation, and many others. Rovelli explains that the apparent existence of time in our perceptions and mathematical descriptions comes not from knowledge, but from ignorance. The true concept of time must be reimagined, according to Rovelli, who is a quantum gravitational theorist. Quantum gravity is a theory that brings together general relativity and quantum mechanics. Well, why should these two things be brought together? Einstein predicts that there is a fourth-dimensional curved spacetime, what we also know as a gravitational field. This is predicted to have quantum properties. This means that Earth's magnetic and gravitational forces behave as quantum mechanical objects, being in superpositions of states. Rovelli has been working on the equations of this theory, and there are no variables of time here. Because of this and all previously mentioned misconceptions of time, our understanding of Newtonian spacetime, which is the idea that time is uniformly flowing, is not correct according to Rovelli. The only description of time that still holds is the idea that time is just a way of counting the change of something. Let's investigate the conditions under which we live and try to give more meaning to how we use time. We are able to disregard aspects of nature because the granularity of time is so small that we don't notice the differences of time, so we think it's continuous. The quantum mechanical aspects of time don't interest us because we are at a scale much larger than the Planck scale, so we don't notice quantum mechanical effects. And the last reason is that we live in a region where gravity is very weak in comparison to other regions, and there are not largely visible relativistic effects of time in our everyday lives, so we disregard it. There is still something missing about time. Why is it that for us we have such strong feelings about the existence of time and its passing? It is very hard to imagine a reality without time, but this is not because reality itself can't be thought of without time, as Rovelli says that it can be. It is just because humans and the human brain are designed in a way that makes it hard for us not to imagine time. The way the brain works is to build memories and anticipate the future, continuously connecting past memories and future anticipation. Philosophers have been saying this for centuries, and it goes back all the way to St. Augustine in his letters. Augustine declares that time for us has great emotional connotations. In his letters, Augustine talks about listening to musical phrases. As he listens to one note at a time, recalling the previous note, there is meaning in the words, but there is only meaning because of the memory that he has of the previous notes themselves. The meaning exists all in the present because of memory. To understand what time is for us, we not only have to look at the temporal structure of the universe, but at the specific functions of our brain. Time is not emotionally neutral to us because we are emotional beings before we are rational beings. This emotional aspect of time is precisely what time means to us, as Rovelli argues. Time for us is this emotional connection that we have with the events of the world and our passage of time in them. Time for us is a multi-layered concept that comes from approximations, our particular relationship to the world, and the function of our brain. Our emotional connection with time is what time means to us. Thank you.